Okay, it came here. Okay, boom. So students, we are live now. Okay. Now all of the candidates who have joined this YouTube, I'm audible for them. I hope. Okay. Okay, so I'll be audible for them. Now I'll be starting this. Okay, let me start this thing. Just hold on, students, 1 second. Okay, students, so let us start it now. As you can see, it's available on the YouTube also. Right? Yes. Let me quit this. Okay. So today, what we are going to study? Today I have already told you that we will be studying about ray optics numerical session. Okay. So till now, what are the things which we have covered? We have covered a plane mirror topic. Okay, I will use different colors. We have covered spherical mirror topic. We have covered total internal reflection and refraction. Okay, total internal reflection and refraction. Okay, so TI.R is what? Total internal reflection. I'm writing the full form. Maybe you have forgotten, maybe it may have happened. Okay, by the way, how are you all? I haven't asked. Okay, you told hello, so I feel that it's okay. So once more student have joined. His name is PC and one is JNV Gondia. Okay, I don't know which JNV is this, but whatever. Good. If okay, so what do you say this? Good afternoon to everyone. Some are saying good evening. Okay, good evening for them. Some are saying good afternoon. Good afternoon for them. Hai. Is it okay, students? Okay. So cloud is also started. Cloud streaming. Okay, let us move to the next. So students, today, as I've already told you, that we will be having this numerical class. JNV PC says Wiki. Okay, JNV Wiki students, how are you? Enjoying the days? So we'll solve the numerical series session. This is today's numerical series session. No, so we'll be solving as per the topic. That is this plane mirrors, spherical mirrors, and what? Next thing is total internal reflection. Okay, so you can see here. Next is total internal reflection. So this first question in front of you, all of you must try to attend this question. Okay, try this question, students. Try out this question. It's an easy question. Question number first. Based on plane mirror topic. Today's numerical session. So the question says what? Question says like this. That okay, hold on. Question says like this. Ki a point source of light is placed in front of a plane mirror. Okay. So what they're saying like this. Suppose you're having a plane mirror like this. I'll just give you a hint here. Okay. So you're having a plane mirror here. This is what a plane mirror. I'm writing a solution. Solution. So we are having a plane mirror like this. Plane mirror. Okay. And we are having what? We are having a point source of light placed in front of the plane mirror. So this is the point source of light placed in the plane in front of the plane mirror. It is what? Source S, which is a point source of light. Okay, it is placed in front of the plane mirror and it is at perpendicular distance d from this plane mirror. So now they're asking from you, which of these options will be correct? Okay, it says if the point source of light is placed in front of the plane mirror, only the reflected rays close to the normal meet at a point when produced backwards. Okay, or all the reflected rays meet at a point when produced at backward, only the reflected rays making a small angle with the mirror meet at a point when produced in the backward. Light of different colors make different images. So what do you say? What is your answer? A, B, A, C, A, D. Students, I can see that you are, switching on your camera, like what? Maybe what you're doing, I don't know. So answer me. A, B, C, or D. What is your answer? A, B, C, or D? Students, A, B, C, or D? क्या आंसर होगा इसका? Anybody? Any one of you student? Anybody? So see here, we'll solve like this. So suppose the rays are going like this. Okay. इसका image कैसे बनेगा? How the image will be forming? It will be forming like this, no? That when extended back, this is the image of the object. So we can say yes. First thing is common, that is reflected rays are 100%. But which kind of? We'll say only those which are like making a very small angle theta normal to the plane mirror. So reflected, all the reflected rays, but which are making small angle theta, only those. Okay. So as per the option, if we check all these ABCD options, we can see this thing. A, only reflector is no. Okay. So we'll say C is the perfect option directly. Only the reflected rays making an angle, small angle theta with the mirror meet at a point produced back close to the normal, meet at a point when produced back. Okay. So we'll say only for those rays. Okay. So we'll say, see, these two options are having like chances because see, you can see reflected rays close to the normal meet at a point when produced backward. Only the reflector is making a small angle with the mirror. So what do you say? With the mirror or with the normal? We can see here easily that it's not with the mirror, it's with the normal they're making the angles. Okay. So we'll write here what? It is A option, not C. Because we are having doubts in the two, rays are not going towards, it's not a spherical mirror case. Okay. Spherical mirror का case नहीं है. इसमें rays are paraxial. No, it's not that. Okay, these are making the angle with the what? This is principal axis, basically the normal to the spherical mirror. Okay. Similarly, it is also making angle theta, which is a small angle with the normal, not with the mirror. So the best option suits here is what? A is the best option. Okay, got it? Yes or no? Write it. A or is it right? Are you able to understand this? Okay, good. Now, students, this question in front of you, second number question, it is also based on the same thing. That is what? Topic plane mirror. Because we haven't solved a lot of questions, no. So you people want a lot of questions, no. That's why this session is completely numerical. Okay. So try to solve this. What do you say? What is the answer? Read this question. I'm giving you 1-2 minutes to solve this, then I will solve it for you. Okay. I'm giving 1-2 minutes to solve it, then I will solve it for you. Okay. 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 So I hope it's visible now again, है ना? So please solve it. Don't waste time. Solve this thing. Solve it fast. Okay. So I am solving it for you. See what this question says. It says like this, that suppose when a plane mirror, it says when a plane mirror AB is placed horizontal on level ground at a distance of 60 meters from, okay, from the foot of a tower. The top of a tower and its image is in the mirror substance angle 90 degree at B. The height of the tower is what? See, it says a plane mirror is like this and it's horizontally on a level ground at a distance 60 meters from the foot. So this is the foot of the tower. You can see, sorry, this is the foot of this tower, no? This building, maybe some like hotels. So this is the foot of this tower. And you know, you can see this thing, it is at what distance? It is at 60 meters distance from this. Foot of this tower and 60-meter distance, okay? And what's the next thing? It says the top of the tower and its image in the mirror substance an angle 90 degree at B. The top of the tower and its image. So how will be the images? Can anybody guess? Yeah. So if it's like this, if we extend it, image will be down somewhat. So it is subtending an angle 90 degree like this. That is 90 degree like this. So of course, this angle will be 45 degree. This angle will be 45 degree. Okay. Now very simple. So solve it. ये length कितना दिया हुआ है? So this length is not given, but this horizontal length is given as 60 degree, 60 meters. Sorry. So we can say like this. The picture, the new picture is this on the next screen. So I hope you are able to see this new picture. Solution. So how this tower building will be looking like? It will be like this. It will be like this. This building will be like this. This is the building. Okay. So we need to find the height of the building. No, you can see this. Yes. Height of the tower is what? Yes. Triangle dimensions. So these are the triangle dimensions. 60 meter is the distance. Okay. And height is this, and this angle is what? This is given here 45 degree. Okay. So can't you find it now? Just apply the trigonometry kind of thing. We can simply apply here tan of 45 degree. We know tan of 45 degrees what? Anyone? Perpendicular on base. And tan 45's numerical value in the trigonometry is what, students? It is, we know, sir, sine 45 upon cos 45. Okay. Sine 45 is equals to 1 by root. Everyone knows. These are very basic mathematics, students. Why? I don't know why you people are not replying. Only one student have replied till. And it will be 1. So 1, I'm writing very basic, you know, in a very basic manner. So h is equals to 60 meters. This is height. Got it? Yes or no? So answer will be 60 meters the height. So you can see from here, height of the tower, that is actual height. So answer is B only. As is the distance, as is the distance, same is the height. Same is the height. Okay? 60, 60, 60, 60, 60, 60. Now let us see the third number question. Yeah. So this question is in front of you. Any one of you can answer. See, the beauty of this question is this. This is a unique one. Why? How, sir, it is unique question? How can you tell it is unique question? How you can say it is unique question? And it's like this. Kaise students, how it is unique? Because if you read it, you will get it. See this. A point object is kept in front of a plane mirror. The plane mirror is doing SHM. Okay, so this is the uniqueness of this question. This is a specialty of this question. That is question me. Geometrical optics concept is fused. The fusion. It's fusion. You know, we see Dragon Ball Z cartoons. Fusion of Goku and Gohan. So this is like geometrical optics and it is having fusion of two things. I'm sorry, in this question there is a fusion of two concepts: geometrical optics plus what? SHM, simple harmonic motion. Okay, so it says what? The point object is kept in front of the plane mirror. The plane mirror is doing SHM with amplitude so 2 centimeter. It means amplitude means what? Plus a extreme position at 2 centimeter from the x0 origin, and x equals to minus a at minus 2 centimeters from the origin. Okay, so plane mirror might be doing SHM like this. The plane mirror moves along the x-axis. Okay, it is written what? Plane mirror moves along the x-axis, and okay, and x-axis is normal to the mirror. Fine, it's like the same thing. I will draw the image again. Just hold on. The amplitude of the mirror is such that the object is always in front of the mirror. Okay. So the amplitude of the mirror is such that the object is always in front of the mirror. The amplitude of the section of the image is what? Anyone of you can reply? I'm giving you time, 2 minutes. Anyone of you want to reply the answer? What do you think? What is the solution of this? Anyone of you students? What is, so I'm giving you minutes, okay? So try it yourself. So I hope you got an idea, and like the minutes I've given you, 1 minute or maybe 1.5. So in that you have used those minutes, and I think you have answered it. So anyone of you can text now. What do you think? The amplitude of the SHM of the image is what? 0, 2 centimeters, 4 centimeters, or 1 centimeters? What do you say, students? The amplitude of the SHM of the image is 0, 2 centimeters, 4 centimeters, or 1 centimeter? कोई बता सकता है what is the answer? Anyone of you will tell what is the answer? Okay, I'll tell you. See, this question में one thing is this: it says the amplitude of the mirror is such that object is always in front of the mirror. Okay, object is हमेशा in front of the mirror. So if you see this slide, इसमें you can see with your eyes, you know, I mean, it's visible that I have moved this mirror in such a manner in which directions, this minus and plus, okay, that it is doing SHM like this, such that the object is always in front of the mirror. See, if I draw its initial image, इसकी image अगर मैं draw करूं, it will be somewhat initially ऐसी, okay, but when this mirror is moving, due to which what is going to happen? Anyone of you? Okay, so what I'll do is that simple students, इसमें कोई बड़ा logic नहीं है. What I need to do is this: if you see the mirror at this position, total displacement is how much? X minus 2, x plus 2. But if you take it as a distance, it's 2 plus 2. That is equals to 4 centimeters, students. This is the maximum amplitude. See what is asked in the question. Amplitude of the SHM of the image. Okay. So that will be equals to 4 centimeters. So objects, mirror will come here, students. When the mirror will reach here, so image of the object will be back here at 4 centimeter, and this is the maximum. So I will take this as the answer, that this is the maximum amplitude of that SHM image. Very logical, you know, you don't go into the depths of the mathematics in this. Just be like physics, you know, I mean, go in the physical significance. So for this, I will write the answer directly as 4 centimeter. क्योंकि ये maximum case हो सकता है. This only can be the maximum case. 2 भी था, but 2 and 4 can be the cases, 0 नहीं होगा, so we'll say 4 is the answer. ठीक है? Okay, now I will not waste time. Let us move towards the next, this question. Okay, this question is a homework for you. ठीक है? चलो मैं ये solve कर देता हूँ, next question homework दूंगा. It is based same. So these questions are also based on plane mirrors, but clock version वाले हैं. Okay, these are plane mirror questions, but based on the clock, specific topic clock. Okay, देखो इसमें बहुत बार कर लिया है क्वेश्चन. इसमें करना क्या, what we need to do in this is this. A watch दे रखी है, उसमें time is what 3:25. So I'll draw a circle. Sir, please draw straight circle. Okay. So suppose I draw a circle like this. This is a plane mirror. 3:25 का मतलब क्या होता है? 12, 1, 2, 3, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. 3:25 का मतलब क्या? 3:25 का मतलब इधर, 25 मतलब इधर. So students, it's like this. The concept is like this. Okay, you can draw this watch on a paper. Concept is what? Answer क्या? They're asking you what? कि plane mirror में image में कितना time आएगा? What will be the time in the image of this clock, which is showing this 3:25 time, PM, AM, I don't know, whatever it's showing. In plane mirror, the image will show what time. Okay, so the concept is this. Draw this concept. Draw this clock with given time. With time given on paper, and look the back side of the paper. Same will be the time in the image, and look back side of paper, or behind, or say like behind of paper. So students, for this case, if you look behind this watch, you'll get time as, what is that? What's the time will be? Time will be, students, 8, something like this, 8:25. Okay, 8:25 will be the time, approximately this. You have to check it out. Okay, it will be either 8:25, 8:35. I'm just giving you a simple idea. You have to check. Okay, so similar looking next question is this. This is the last question based on this plane mirror concept. So I'm giving you this as homework. Similarly, you have to use the previous question concept. Right? What was the previous question concept? Previous question concept was this. Just draw the watch on a paper, okay, and mention the time there, and then look behind. You will get the image. Also, you can draw the ray diagram straight, and straight you will get an idea. You know how? What the ray diagram? Ray diagram के लिए क्या करना होगा? It's like this, students. एक प्लेन मिरर लिया, ऑब्जेक्ट लिया, उसका डिस्टेंस अगर d इतना है ऑब्जेक्ट से, तो इमेज का डिस्टेंस भी तो इतना होगा ना. This was the way, no? We draw the ray diagrams. You can use this concept also, or you can use this, draw the image and look behind the paper. Only specifically for plane mirror questions, and that also, in that also, students, when we are mentioning this clock topic. Okay? Okay. So we have completed. If we see we do conclusion is this. Okay, now let us start the spherical mirror. Now we'll be starting soon the spherical mirrors. Okay, visible हो रहा है ना on the screen? Yes, visible होना जरूरी है. Okay. So now we'll be seeing the spherical mirrors. Okay. So let us start it. The first question in front of you from the spherical mirror, solve this. It says what? It says what, students? Any one of you? Can you give the answer? चलो मैं ही कर रहा हूँ सारे क्वेश्चन सॉल्व. Just wait here. In image formation from spherical mirrors, only the paraxial rays are considered, because अगर तुम्हें, if you know the meaning of this paraxial rays, then you can answer. Are easy to handle, contain most of the intensity, form nearly point image, show minimum dispersion effect. What is your answer? A, B, C, or D? Any one of you can answer, students. Any one of you can answer. A, B, C, or D? A, B, C, or D? The reason is this, students, they form the nearly point. Paraxial rays are what? First of all, let me ask from you. Let us revise this concept. What are we are just going to in the next class? And you people have studied this much a lot. Okay, so at least you must answer these one-word questions. No. Paraxial rays क्या होते हैं? Paraxial rays are those rays which make, consider like this, which make very small angle with principal axis, but which make very small angle with principal axis. Paraxial rays are these rays. Okay, समझ में आ गया? So based on this concept, you will write अगर वो shows that it will show a point image of the source. Okay? If the rays are like very far away from the principal axis, you will not get a point image. A blurred image also you'll get. Now this question, students. I'll be solving this watch here, okay? Solution. So suppose a concave mirror, okay, of a radius of curvature. Its radius of curvature is given as 20 centimeter. Okay, it forms the image of the sun. And the diameter of the sun subtends an angle 1 degree on the earth. So it's like this, students. Then diameter of the image. So it's very simple question. So what they are saying, they're saying like this. Suppose this is a principal axis and the mirror is like lying on the earth. Okay. If the rays coming from the sun is making an angle 1 degree, 1 degree, of course, if it's falling on the pole, many rays will be there. No, some will be coming here, some will be coming here, but I am considering this pole ray, the ray which is falling on the pole, incident on the pole, making an angle I equals to 1 degree with the pole. So the reflected angle will be also 1 degree only here. Okay. And now diameter of the image, they're asking you, diameter of the image in centimeters. So solution. कैसे करेंगे इस क्वेश्चन को? Any one of you? Concave mirror, axis. This angle is 1 degree, 1 degree. Focus. See, radius of curvature कितना दिया है? It is 20 centimeters. 20 centimeters. Radius of curvature is 20. Focus will be how much? We know. What is it? R by 2, 10 centimeters. So students, I will use that law. I will take like this. Focus, I know it is equals to 10 centimeter. Let me mark with some other colors. It's 10 centimeters. Okay. So if focus, we know this thing, theta is equals to arc upon radius. Okay. So if you want to find the arc subtended or the projection, you need to find here in this case, you will write theta into radius. So radius here is like focus. Theta is 1 degree. Okay. So through this, you will get an ultimate thing, that is what? Diameter of the image. वो कितना आएगा? Any one of you? Diameter of the image. Diameter कैसे ढूंढेंगे students? It's like this. See. We'll write here 10 centimeter into 1 degree, but in radians. So for that, I know that if you want to convert 1 degree into simple numbers, we know pi is equals to what? 180 degree. 1 degree is equals to what? Pi upon 180 number. Put it here. Pi by 180. We'll get the answer as pi by 18. Okay? So your answer will be D here. Pi by 18 is the answer. See, never get confused with the language of the question. Questionnaire will always like try to bound you, and like trap you in something kind of illusions and all these things. But don't have to worry about that. Just cling with the concept. Okay. Now we'll see the next thing. This question. This is also a very fantastic question. Okay. I mean, easy question, but conceptual. If you know the application, if you know the formula, then only you can solve. Okay. No worries. I'll be solving this. Just see the solution. I'll give you the PDF. Okay, if you're not practicing in the class, don't worry about that. But at least when you are in after the class, I mean, you can practice in the night time or in the morning from the PDF at least, not before coming to the next class. It is for your well-being, okay? So solution here. This question में कह रहा है कि a candle is kept at equal to double the focal length of the pole of the convex mirror. So convex is bulged outwards. This mirror is like what? Bulged outwards. This is a pole of that mirror. It's kept at equal to distance, double of the focal length from the pole of the convex mirror. So I will consider that candle to be like this. Twice of F. Pole P is this point, and its focus will take here. Its magnification there. Magnification hota kitna hai? Magnification, I don't know, maybe the image is erect, literally erect or inverted, and height is more or less, I don't know. We'll find it now. But magnification, they're asking you. You know the magnification formula is given by what? Any one of you? Height of the image, height of the object, minus V by U. With, then never forget this thing, with sign and conventions. With sign and conventions. Got it? Sign and conventions. Okay? Sign and conventions. So let us try to solve this question also. So if I find, we know this thing, if we go against the object rays, it is negative. If we go in the direction of object rays, it is positive sign. Up is what? Positive. Both on this side and this side. Negative. Down is what? Negative. Apply these things. So here you can see this thing, object distance, because we use this letter, that is U, for mentioning object distance in physics. Object distance here is what? Twice of focus. With sign and convention, negative. From the pole we are measuring. No. Image distance, V is for image distance. V is for image distance. That I don't know. Focus is positive, by the way, because it's what? Convex mirror. Apply the formula 1 by V plus 1. It's a mirror, okay? F. Put these things. So when you are going to put these things, 1 by V, you have minus 2F. 1 by F. So this will be 2F plus 1 by F. This is equals to 3 by, not 3 by, it is equals to how much? Any one of you will write like this, 1 by 2 plus 1, 1 by F, common. So what is the answer? Okay, so we'll get like this. I'm mentioning here 3 by 2F equals to 1 by V. V is equals to 2F by 3. Okay, now they're asking us magnification. I'm marking it as first equation. We got V is equals to 2F by 3. Okay, put this here. V equals to 2F by 3. U kitna hai? Minus F. Sorry, minus 2F. So minus and minus, this blue color will cut. 2F2 will cut, 1 by 3 will come. So we'll get the magnification as 1 by 3. Excellent. Jinvi Gondia student says repeat it. Okay, I'll repeat it for you, Junbi Kondia students. देखो इस क्वेश्चन में क्या कह रहा है, what it says इस क्वेश्चन में, it says like this, एक कैंडल है उसको, ओके ओके, तो इस क्वेश्चन में क्या कह रहा है, सपोज आई एम मेंशनिंग इट हियर अगेन, रिपीट, आई एम रिपीटिंग इट हियर. इसमें इस क्वेश्चन में ये कह रहा है, इट सेज लाइक दिस, सपोज यू आर हैविंग अ कॉन्वेक्स मिरर. कॉन्वेक्स मिरर मतलब क्या होता है, ऐसे bulged out, and it says like this, suppose from the convex mirror at 2f distance, where f is what, where f is the focal length of this mirror, this point, itna distance, p is the pole, a candle hai, object is what, candle here, which is kept at 2f distance, and in this question they're asking you the magnification of the image. And we have studied in the previous classes that magnification of the image is given by height of the image, height of the object minus v by u. But all these things with proper sign and conventions. ठीक है, अब इसमें वैल्यू ही तो पुट करनी है. यूज द फॉर्मूला. कॉन्केव और कन्वेक्स स्फेरिकल मिरर के लिए फॉर्मूला सेम था ना, लाइक दिस. Now put here u is equals to, u कितना लिखेंगे, because we are going against the direction of the rays, u minus 2f. जब आप इसमें ये पुट करोगे, you will get v finally as what, क्या आएगा, 2f by 3. और magnification is defined as, क्या defined है magnification, it is defined as minus v by u, height of the image upon height of the object, but I am solving it here. minus 2f by 3, u कितना है, minus 2f. Solve करेंगे, we'll get 1 by 3 as the magnification. I hope JNV Bondia students you understood. So इसमें आंसर क्या आएगा, आंसर आएगा magnification. Did you understood? Very good, very intelligent. So you understood just in one repetition. Okay, you are saying there is one more formula. Which formula? No, 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 no. That is not for this. That is for image. That is for image speed. I told you, no. Separate the formulas, okay? देखो formula जो आप कह रहे हो, that formula is not for this. That is for this. Velocity of image with respect to spherical mirror minus of v square upon u square velocity of object with respect to mirror. इस case में it's like this, whether concave or convex, object must be moving. Object की कोई speed होनी चाहिए. Velocity of the image, or sorry, velocity of the object, then only the image will be having some speed. But in this question, none of the thing is moving. ये move नहीं कर रहा, it is at rest. Image will be at rest, but there will be changes in the height only. Got it, JNV Bondia students? Okay, so Bondia students, okay. So now let us move towards refraction part, okay? So what we will answer, now we have reached the refraction part, C part, we have done all those questions. One question we'll leave it, no issues, but this question we must start before ending, because this is our ending section. Time like 15 minutes are remaining. So answer this. Okay, JNV Gondia students, you're participating, answer this. JNV, Yavtamal, JNV Gondia, JNV Sangli. What about you? You people, you know, you used to study a lot, I know. So answer it now. This is a question from the section C. I told you in the contents, reflection and TI.R, total internal reflection. So when a wave is refracted, क्या होता है? अगर एक wave ऐसे आती है, it comes like this, making an incidence, and this is denser and this is rarer medium. Of course, it will bend towards the normal, where I is greater than R. We know this thing, no? This is what process? This is the phenomenon of refraction. But they're asking from you, जब ये wave refract करेगी, तो will the path change, amplitude change, velocity change, the frequency change? What do you say? What is the answer? Any one of you? Now reply. Reply, students, reply. We are having few minutes. क्या आंसर होगा? What is your answer? Very simple. We know one thing, frequency change नहीं होगी. I've already told you in the theory. Okay. Path change होगा. Path also will not take. amplitude nahi, velocity, because we know the formula. What is the formula? mu1 upon mu2 v1 upon v upon. If you see, I've given you specifically this formula with the angle, say mu1 is equals to mu2 in r upon sine I. You know, applicative formula, the main formula from the Snell's law. You have derived, no? Hai na? Very good. So this will give you C as the answer. Velocity because we know अगर like this boundary surface, speeds भी different हो जाएगा. Okay, speed बोला है, velocity बोला है, तो we'll mark C as option. Good. Good students, genuine Sangli students, if you participated. Now students, this is a question, very easy questions. Okay. So, but before solving this question, let us move towards, okay, let us solve this. Okay. Then we'll move towards the best. I mean, the last question of this today's. Because question में क्या रहा है, I'll show you the picture, but just hold on. इस question में क्या कह रहा है? What it says? The XZ plane separates two mediums AB with refractive index mu1, mu2 respectively. देखो ये picture. देखो ये XZ plane है. Two mediums are separated mu1 and mu2. Okay. A ray of light travels from A to B. Its direction in the two mediums are AB, alpha, beta. So it's like this, students. So side by side, A इतना है, B vector ये है, ठीक है? And इसमें alpha vector is this, and beta vector is this. This is beta distance. ठीक? उसमें this is B distance. इसकी लेंथ ढूंढोगे तो ये आएगा a square plus b square. इसकी लेंथ ढूंढोगे तो ये आएगा अल्फा स्क्वायर प्लस बीटा स्क्वायर. ठीक है स्टूडेंट्स. सो इसमें पूछा क्या है, इसमें दे आर आस्किंग फ्रॉम अस, देन यू हैव टू फाइंड अ रिलेशन, चेक आउट द रिलेशन. सो सिंपल स्टूडेंट्स, इसमें स्नेल्स लॉ दे हैव यूज्ड. You can see yourself the solution. I've already pasted to save the time because I knew, no, it's automatically at last we're not having a lot of time, है ना? So what you will write here? mu1, which is the refractive index of this medium, sin I, which is the angle this इसका sin I, मतलब perpendicular upon hypotenuse. Perpendicular कितना है? Perpendicular है A upon hypotenuse. So perpendicular upon hypotenuse, A plus B का square. ठीक है? And this is mu1, and next is what? mu2 sin R. mu2 R angle is this, that is perpendicular upon hypotenuse. Perpendicular कितना है इसमें? इसमें alpha perpendicular है. So perpendicular upon hypotenuse, alpha square plus beta square. This is hypotenuse. Hypotenuse. जब इसको हम solve करेंगे, because here what is given is this, that we are treating A, B, alpha, beta kind of. Okay. So we'll cancel this down portions. Length is same. I will take U1 equals to U2 alpha, which is the answer. That is U1A, U2 alpha is this answer, which is the right answer. A is the option, students. देखो इसमें ज़्यादा दिमाग नहीं लगाना, it's just complete mathematics. इसमें इतना physics नहीं है. Only the theory you have to apply it here directly. ठीक है? समझ में आ गया? Very easy. Now last question of today's class, a very good quality question, which is this. चलो ये तो तुम बताएं, ये this is not actually that question, but actually you, I mean, at least you must tell this answer. You know, हमने पढ़ा है, इसका आंसर one word answer है. Even you, it's not required for you. Okay, you can use the application here. You know, solve करो इसको, क्या आएगा? देखो इसमें क्या लिखा है? A ray of light passes through a plain glass slab. देखो ये like this. Next. ग्लास स्लैब है, इसका रिफ्रैक्टिव 1.5 है. A ray of light passes through a plain glass slab. Denser है towards like this. When it will come out, it will be again parallel. So this I and I dash E, which is emergent ray, I will add incident. We have studied this article, no? Incident ray and emergent ray are parallel अगर दो चीजें पैरेलल होती हैं तो इनके बीच में एंगल कितना होता है? 0 डिग्री। दैट इज देयर आस्किंग, यही तो पूछ रहे हैं। दे एक्चुअली कंफ्यूजिंग यू हियर स्टूडेंट्स, वो आपको कंफ्यूज कर रहे थे इसमें। A ray of light passes through a plain glass slab. Okay, so they will be actually parallel. A little shift होता है, they are not asking you that, but they are asking the angle between the incident and emergent ray. Since we know these are parallel rays, we will take angle to be 0. So ये आपको actually confuse, the examiner want to confuse you actually by giving this thickness and all these things. ठीक है? Yes or no? Yes. Sangli students are there? Yes. Okay, note down here. Sangli students then Vayatman. Okay. So now let us see the last question of today's class, which is this, and then I'm going to end the class. ठीक है, ये क्वेश्चन तो सॉल्व करो. Give me the answer. Okay, let us solve together. Let us see who wins. Just apply the formula of apparent depth, normal depth, real depth, apparent depth, and refractive index ratio equal to me. You will get the answer. Okay, very good. देखो ये क्वेश्चन क्या कहता है, हाउ मच वाटर शुड बी फिल्ड इन अ कंटेनर ऑफ 21 सेंटीमीटर इन हाइट so that it appears half filled when viewed from the top of the container. Take the refractive index this. Assume near normal incidence. It says like this, if you fill a container, how much water you must fill in that container of 21 centimeter height such that the container appears half filled. So this is the picture for you. Let's suppose you fill it with X, okay, such that it appears half filled, okay, and this is the height of the container, that is 21, okay. Half filled का हमें half filled चाहिए, it appears to us half filled, so I will write the fake height as 21/2. Fake height is this h2 corresponding to apparent depth. Apparent means what? Fake. I will write the fake height is equals to half filled. It is, see, half filled is not the actual thing, but they say that it must appear. Appear मतलब क्या होता है? Fake. Appear मतलब क्या? It appears, but actually it is or not, we are not sure. वास्तव में it is or not, we are not sure, but it appears, it may be fake. So we'll let half filled. Half filled मतलब 21 का 2. ठीक है? So they're asking the amount of water filled. I mean x height. कितना height होना चाहिए water का? Simple students. Right here 21/2. नीचे I don't know the amount of water height which must be filled in this container. उसके लिए x. Write the refractive indexes. ठीक है? Mu of air, because we are seeing I is above. Our eyes are here. It is in air. And water is this inside. So mu of air on the top, because this from here apparent will able to see, it will appear to our eyes. And x, which is the actually the filled water, it's making up water में. ठीक है? It's in illusion is where illusion is in water. So right here 4/3. ठीक है? Because that is the refractive index of water. अब इसको solve करते हैं. Let us see the answer. So when you will solve this thing, last question students, इसके बाद end करेंगे. 21/2 is this, is their demand that it must appear to us. X is the filled water. Water में water का refractive index 4/3 equivalent में. Air में, because this our eyes are on the air, in the air, rays are coming like this. So 1 of refractive index of air. अब इसको solve करना है और amount of x height, I mean amount मतलब नहीं, length height of x water. What is this? X मतलब कितना water fill किया in this container such that it appears to be half filled. X we need to find. Simple mathematics. 21/2 4/3 equals to x. कितना आएगा ये? Anyone of you? 2 2 is 4, 3 7 is 21. So we get x equals to 7 2 is 14 centimeter. X is 14 centimeters. Okay, we are having the option yes. So students, from this we get D is 14 centimeter, and this is the last question. Now we'll end the class. If anybody is feeling any doubts, please students text me now. We solved all the questions which, I mean, based on the theories which we have studied in the previous classes. Okay, got it? So answer me students in class. Okay, I mean for your attendance. If you're facing any doubt, you can ask. Any doubts from the previous lectures, or any, like, you want to give any feedback, any kind of, you can participate here. Okay, any doubts, students? Or we can solve one more question if you want. 2 minutes. PDF as homework, okay? देखो मैं आई एम नॉट रीडिंग दिस क्वेश्चन बिकॉज वी नॉट हैविंग द टाइम. इसमें कुछ नहीं पूछा, बस दे आर आस्किंग फ्रॉम यू द शिफ्ट. शिफ्ट का फॉर्मूला क्या था? इट वाज थिकनेस ऑफ द स्लैब 1 minus refractive index of the medium upon refractive index of what? Slab. ठीक है? Solve this. You get shift. If I have told you this thing, if shift is positive, it means in the direction of rays. If shift is negative, it means opposite to the direction of rays. ठीक है? देखो इसको now also we can solve just hand in hand also because there I have already told you they're asking from you the shift कितना होता है. So जल्दी से solve कर सकते हैं. It's very easy by the way. Apply the values. Okay. बस इसमें याद रखना, it's in this question the velocity relation is also given. So you will write like this: mu of medium, mu of slab, corresponding velocities. Corresponding velocities are like this. Medium में कितना velocity है? It's 9/4 into 10⁸ और slab में कितना velocity है? Slab में they are giving the velocity as 1.5. ठीक है? इन दोनों की जगह पे replace this thing there. You'll get the answer. Okay. Okay. Bye bye. I'm ending the class. We'll meet in the next class. Be happy. Enjoy the day.